everybody! We're in Unit 3, Lesson 2, the product rule of exponents, and it starts out with this vocabulary. So they have base, the number multiplied repeatedly the number of times indicated in its exponent. An exponent, the number of times a number is multiplied by itself, also referred to as a power. And so what you need to know here, so if I was taking notes, I would write the date. I'm recording this on the 21st. And then this is Unit 3, Lesson 2, Product Rule of Exponents. It's helpful to write that title. Okay, and then what you really need to do here is hopefully write an example. So let's take 2 to the third power. Okay, the base and the exponent. 2 to the third power is 2 times 2 times 2. Okay, so when they say the number that's multiplied repeatedly, that is the 2. The exponent is the number of times the number is multiplied by itself. So that's 1, 2, 3. That means our exponent is the 3. And let's put in quotes here, this is sometimes called the power. All right, I'm going to show you some examples now from this lesson, okay? But you'd probably want to write, you know, these other terms if you need them, integer and product. And then when you read through the lesson, you might see some other things that are helpful to you. You might want to write down some of those examples, okay? But I'm going to go ahead and look with you at this product rule, okay? So let's see where they tell us the product rule, okay? So the product rule. Okay, there are 7, so x to the second times x to the fifth is x to the 7th. Okay, so product rule. I'm going to write it nice and big in my notes, and I'm going to say that x to the second power times x to the 5th power is x to the 7th power. Okay, which they have demonstrated by rewriting those in an expanded form there. Okay, and then right here, this is what I'm going to write down. The product rule of exponents says that when multiplying like bases, add the exponents. Okay, so the base is the bottom number, the big number. So we have x as the base here, x as the base in the second, right? Here's x in the base. Okay, we add 2 plus 5, and that's how we get the 7. Okay, let's do some examples of this. So this is from page 10, okay? And this I wanted to talk to you about because it took all the way to page 10 until they finally had an integer, a negative number in the exponent, and those are the ones that are going to be a little trickier or that are going to look funny. So it says find the numerical equivalent, I want to talk about that too, of 6 to the 8th times 6 to the negative 5th. So 6 to the 8th times 6 to the negative 5th. Okay, what I'm noticing here is that they have like bases. They both have 6 as the number that they're multiplying. Okay, the rule says that we can add the exponents. So this will be 6 to the power of 8 minus 5. All right, and then 8 minus 5 is 3. Okay, let's talk about the numerical equivalent. What I would say here is we want to get one number as our answer. So we're going to actually perform this multiplication, 6 times 6 times 6. Okay, and you can do that in the calculator, that's fine. I'm going to enter 2 plus 2 in a Google search. I'm going to clear that out. I just do that to get the calculator up. I put in 2 plus 2. 6 times 6 times 6, okay, is 216. And so that is what they want here for the numerical equivalent, is 216. Okay, and there's another button on here that you can use. See this button here that says x to the power of y? Let me show you that. So if I do 6 and then I hit x to the power of y, I can type in the exponent of 3. Okay, so look on your calculator to see if you have that button. So x to the power of y, and then you can enter 6, that button, and then 3. Okay, let's try another one. All right, so this is a quick check problem. Okay, it says which expression is correctly developed to use the product rule. Okay, I'm going to just fold this paper so that you can see it a little better. And then let's reread what the product rule said. It said when multiplying like bases. Okay, so there are two things going on here. You need multiplying and you need like bases. Those are our two conditions for using this rule. Okay, so let's look at our choices here. Okay, first one, are we multiplying? Yes, we are. Okay, that dot in between 6 to the second power and 7 to the third power means multiplication. Do we have like bases? Okay, and for this first one, the answer is no. The bases are 6 and 7. Okay, so like bases, not for this first one. We can't have a 6 here and a 7 here and expect to use the product rule. Okay, look at this second choice here. Are we multiplying? Not exactly. I mean, the idea with the multiplying is that we're multiplying two expressions. So here's one expression and here's the other. We only have one expression in this next one. Okay, so I'm going to say no to multiplication. And then like bases, we only have one base. So how could it be like something if there's only one of them? All right, look at this one, 10 to the 8th power times 10 to the 8th power. Oh, wait, let me cross this one out. So these, are we multiplying? Yes. There's that dot there between the two expressions. Do we have like bases? Yes. 10 is the base on both of those. Okay, so this is the correct answer here. Okay, and this next one, we're going to use a rule for this later on. There's a rule that you can use for this one, but we'll learn it later on. This is a base raised to a power, and all of this is raised to another power. Okay, we'll learn a rule for that later. So the correct answer for this one is 10 to the 8th times 10 to the 8th. That is the one where you can use the product rule and add the exponents. All right, guys, that's all I have for you today.